All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH022. This is on Objective 12, and Objective 12 continues a discussion about exponents, but we now start to get into some other types of exponents. So you're going to notice here there can be an exponent of 0, and then we can work with negative exponents. So let's do a bunch of these examples. Remember, in the reference packet, you have these rules for exponents. So one thing I'm going to come here is the 0 power rule. We're going to use that. And then down here, you can see there's negative exponent rules. We'll use those as well. All right, so let's do a few examples. Let's come here to exponents of 0. Now, if you remember, an exponent tells you how many times to multiply a base times itself. So when I see this exponent 3, it's really telling me to multiply the base 5 times itself 3 times. But what happens when you have an exponent 0? Well, there's a special rule for an exponent 0. Notice it says here, any number raised to the 0 exponent is equal to 1. So 5 to the 0 is equal to 1. 396 to the exponent 0 is equal to 1. So really anything raised to the exponent 0 is equal to 1. So let's come here. It has negative 4 to the exponent 0, but anything raised to the exponent 0 is 1. How about up here? It has 3 times 2/3 to the exponent 0. Well, 2/3 to the exponent 0 I know is 1, but I have to bring this 3 down with me, so 3 times 1 gives me the answer 3. Now, I have to be a little bit careful because I might see an expression like negative 5 to the 0. Now, this negative sign is not inside the parentheses. So that negative sign is not being raised to the exponent 0. So I'm just going to work out 5 to the exponent 0. Well, that's 1, but I have to bring this negative sign down with me. So be careful. If the negative sign is out in front of the parenthesis, it's not part of the base. All right, let's do a couple more examples here. How about if we come here, it says, rewrite the following without an exponent. All right, well, here is a negative exponent. How do we interpret or work with a negative exponent? Well, here is a rule that says it's the negative power rule. Let me write this down. It says if you have a base to a negative exponent, you'd like to rewrite it and get rid of the negative exponent and be left with a positive exponent. So what you could do is put this expression on the bottom of a fraction, and it flips the exponent to be positive. So b to the negative n is 1 over b to the positive n. So in our example, 5 to the negative 2, I'm going to rewrite it as 1 over 5 to the positive 2. Again, we're using this rule right here. But they want me to write it without an exponent. Well, I know 5 to the exponent 2 is 5 times 5, 25. So my final answer here is going to be just 1 over 25. Okay, so this is the rule on how to get rid of a negative exponent. You move it down to the denominator or the bottom of a fraction. By moving it down to the bottom, it changes the sign of the exponent from negative to positive. I might also have a negative exponent down on the bottom of a fraction. Let me give an example of that. How about if I have an negative exponent down on the bottom? Well, anytime you move an expression up or down in a fraction, it flips the sign of the exponent. So if I have a negative exponent down on the bottom and I move it up to the top, it's going to flip it to be a positive exponent. Let me give you one more example of this. How about if I had x to the negative 7 over y to the negative 5? Usually we want to get rid of negative exponents. Well, if you have a negative exponent on the top, move it down to the bottom, it flips it to be a positive exponent. If you have a negative exponent down on the bottom, move that up to the top, flips it to be a positive exponent. So this is a handy way to get rid of negative exponents. All right, let's do a couple more examples here. Let's take a look at this one. right. This is a little different because this has a fraction to a negative exponent. All right. Well, let me use this rule that says if you have a fraction to an exponent, you could take this exponent and apply it separately to the top and the bottom of the fraction. Let me give you an example of that. Let's say I had 2 over 3 to the exponent 4. Well, that rule says take this exponent 4 and apply it to the top and the bottom separately. So I could write it as 2 to the 4 over 3 to the 4. Well, let's do the same thing for our example. I'm going to take this exponent -1 and apply it on the top and the bottom. So that's going to be 3 to the -1 over 5 to the -1. But notice this problem says you want your answer to not have any exponents. Well, now I can use this negative exponent rule. It says if you have a negative exponent on the top, move it down to the bottom of the fraction. That'll flip it to be a positive exponent. If I have a negative exponent on the bottom, I'm going to move that upstairs and make it a positive exponent. But 5 to the 1 is 5, 3 to the 1 is 3. So my final answer here is just 5 over 3. Again, notice how we use several of these exponent rules to keep simplifying until we get to a final answer that can't be simplified any further. All right, let's do a few more examples. All right, here's one that says rewrite without using a negative exponent. All right, well, they're giving me -6 n to the -5. This n to the -5, I want to get rid of the negative exponent and make it a positive exponent. Well, according to this rule, if I move that expression down to the bottom of a fraction, it's going to flip to be a positive exponent. Notice I'm leaving the -6 alone because that doesn't have a negative exponent. The number is negative, but it doesn't have a negative exponent. So I'm just leaving it alone. So here is the final answer on this one. All right. Let's take a look here. Product rule with negative exponents. All right, well, here's a kind of a messy expression. And notice I'm seeing both positive and negative exponents. Well, let me write this down. And you might remember one little shortcut we used last objective was to reorder an expression like this to put all of the letters next to each other. All right, so, and all of the numbers next to each other. So I'm going to take this 5 and this 8 and this 2 and put them first. Remember, I can reorder a multiplication any way I want. Maybe I'll put the W's next. Here's a W to the -9 and a W to the 7. Maybe I'll put the X's next. Here's an X to the 3. Here's an X, but I'm going to write that as X to the 1. And then here's a Y to the -6 and a Y to the +6. All right. Well, now I can just simplify each one of these expressions. Let's do the numbers. 5 times 8 is 40. 40 times 2, that's 80. All right, let me come over here. I have W to the -9 times W to the 7. Well, if you remember this product rule, it says when you're multiplying the same bases, you keep the base but add the exponents together. Now, this product rule works if the exponents are positive or negative. It really doesn't matter. So I'm going to write this as W to the -9 plus 7. But -9 plus 7 is 2. So I'm going to write that as W to the 2. Excuse me, -2. -9 plus 7 is -2. Let me come to the X's. Well, I'm going to keep the base and add the exponents together. 3 plus 1 is 4. Let me come here to the Y's. I'm going to add together -6 and +6, but that's a 0. All right, let me do a little cleanup because it says use only positive exponents in your answer. Well, I've got to get rid of this W to the -2. The way I'm going to do it is move it to the bottom of the fraction. So I'm going to put W to the +2 on the bottom. I'll have 80 on the top. I'll have X to the 4 on the top. And this y to the 0, this is really equal to 1. Remember, any base to the exponent 0 is just a 1, so I can just leave that out. So here is my final answer. 80x to the 4 over w to the 2. So I think it's a good idea to reorder these kinds of expressions, to put the numbers next to each other, put the same letters next to each other. Then you can use the exponent rules to simplify. If you need to get rid of negative exponents, this rule right here will be useful. All right, that's called the product rule. All right, let's go here. All right, let's take a look at this one. All right, well, this is a fraction being raised to an exponent. Now, the exponent is negative, but of course, when it comes to these rules for exponents, these work for positive exponents and negative exponents. Positive exponent and negative exponents. So it doesn't matter. I can use these rules for any kind of scenario. All right, well, let's take a look at this. Well, I'm noticing what I have is a fraction to an exponent. Here is the rule for a fraction to an exponent. This says take the exponent and apply it to the top and the bottom. All right, so I'm going to do that. I'm going to apply the -2 to the top and the -2 to the bottom separately like this. All right, let me look at the top of this fraction. It looks like I have a multiplication being raised to an exponent. Well, that's this rule right here. This rule says I could take the exponent outside the parenthesis and apply it inside the parenthesis. So I'm going to take this -2 and apply it to the 2 and also apply it to the x to the 6. So I'm going to have 2 to the -2, x to the 6 to the -2. Let me go to the bottom of the fraction. The bottom, I have one exponent, -5, being raised to another exponent, -2. I'm going to come to this rule. When you have one exponent being raised to another exponent, this is where you multiply the exponents together. Well, I'm going to multiply -5 times -2. That's +10. All right, let me keep going. Let me take care of this x to the 6 being raised to the -2. Well, this is that rule we just mentioned where you multiply the exponents together. So 6 times -2 is -12. All right, I'm almost done. Notice it says write your answer using only positive exponents. So anywhere I see a negative exponent, I'm going to move it down to the bottom of the fraction. So this 2 to the -2 is going to get moved downstairs, make it 2 to the +2. X to the -12 is going to get moved downstairs. That's going to be x to the +12. And this y to the 10, I'm just going to leave as is because it's already a positive exponent. Well, I need a placeholder for on top of this fraction, so I put a 1. The only other thing I could do is let me simplify 2 to the exponent 2 because I know that's 2 times 2. That's 4. So I'll write the final answer as 1 over 4 x to the 12, y to the 10. I can't simplify this anymore, so this must be the final result. All right, folks, hope this is helpful as you're working in the subjective dealing with negative exponents.